Hello students, my name is Renu Jaiswal and we are studying square and square roots. Till now, we have studied finding the square root by repeated subtraction, and there was one method. First one is repeated subtractions and the second one was factorization, prime factorization. Now the third method is finding square root by division method. What we do here, suppose I have a number 144. So the process is you have to start pairing from the ones place. So this is ones, tens, hundreds. You have to pair the number. At the end, I have one left. Now we have to do division, and how it is that? In regular division, you take one digit, but here we take two at a time, means pair. So after pairing, one is alone. So I'll take one alone and then I'll move into pair. I'll show you how. First, if I have one, I have to write one number here and one as quotient, such that the multiplication of these two should not exceed 1. And the condition is the number written at this place and at the quotient has to be same to same. So I will write 1 and 1. As I know, 1 into 1 is how much? 1 only. So it is that. So 1 ones are 1. Then I subtract it the way we do in division and it is 0. Now what we do? We take next one digit in regular division. But here we take two digits together, the one we have paired. So I'll take 44. Now one more thing here we do is this number, the divisor and the quotient, the last digit of quotient, I need to add it here. So 1 and 1, it will give you 2. The process is same. I will write one number here and 1 at the quotient. That number has to same. And multiplying these digits together with the last digit. I repeat, multiplying these two digits with the last quotient only should not exceed 44. So suppose I have 2 over here and I write 1 and 1 here. So 21 into 1 is giving me 21, which is very less than 44. So what I'll write? I'll write it here in place of 2. I will write in place of 1, I will write 2. So 2. Now it is 22, this number, and the quotient is 2, which is giving me exactly 44. So 44, and then as in regular division, subtract. And I got 0 as remainder, so need not to do further. My answer is 12. So simply I can say square root of 144 is 12. Let's take one more example. Suppose I'm taking 4096 and need to find out the square root of this number. So what we do? We simply draw the line. Now start pairing from the unit place. So 9 and 6 is one pair. 4 and 0 is another pair. Now I need to decide quotient, divisor and quotient such that they both number has to same and the multiplication of these two should not exceed 40. So see, if I write 5 here, 5 here, 5 5s are 25, which is very less than 40. I can take 6, 6 6 are 36, which is again less than 40. But if I take 7 here and 7 here, so 7 7s are 49, which is bigger than 40. So I will stop myself as 6 6 are 36. So here 6, here 6, 6 6 are 36, and then simply subtract it. So it is 4 and then 0. Next step is take the next pair, that is 96, correct? One more step, I need to take this 6 and add it here. So 6 and 6, 12. Now the next step is take number here and here. These two has to same and multiply only the last digit with this full number so that it should not exceed by 496. I do it by trial error. Suppose I take here 2 and the last digit I'm placing 3. So I need to put quotient also 3 and multiply it. So 3 3s are 9, 6. 396, which is little less. Let's move little higher. So 1, 2 I already have, and the third place I'm putting 4. So I need to put quotient also 4. So 4 4s are 16, carry on 1, 4 2s are 8 plus 1, 9 and 4. Exactly it is coming the same. So I'll write 4 here and 4 here. The multiplication is 496 and subtraction is 0. So my square root is 64. So I can say square root of 496 is 64. Maybe initially this method is difficult for you, but as you move, you will feel this is easier because in prime factorization, we need to see for the factor, especially for a number like 529. This is not getting divided by any of the number initially, but when we come to know, it is getting divided by 23. But trying those many numbers will take a lot of time. That is why this square root method, especially division method, is very useful. Let's learn the next topic. Like here, if a digit is of n digit, n can be even or odd, means the number for which I'm searching for is square root. Suppose this is 4096. The number of digit is how many? 1, 2, 3, 4. I have 4 digits, which is even. So if I have a number who has n digits and it is even, then square root will definitely have n by 2 digits. Clear? Or if it is odd, like take the example of 144. The number of digit is 3, which is odd. Then the number of digit in its square root will be n plus 1 divided by 2. How? Let's check. Here I have 4096 and its square root we have seen it is 64. I have 4 digit which is even divided by 2 is 2. That is why the square root has only 2 digits. Now take the example 144. It has 3 digits. So which is odd? Substitute here 3 plus 1 divided by 2, which is 4 divided by 2 means 2 digit. And that is why the square root of 144 is 12, which has 2 digit. Similarly, suppose I have 9, 6, 7, 8, 2, 5, 0, 0. How many digits it has? 1, 2, 3, 4, 5, 6, 7, 8, which is even. I'm not sure whether there is a square root for this number or not. But as the number of digit is 8, and if the square root possible, the number of digit in its square root will be 8 divided by 2 means 4 digits. Clear? Okay. Now coming to the square roots of decimal. It's a process is same, square root of decimal by division method. Take one example. Suppose I have 17.64 and I need to calculate the square root of it. So what I do? Again, I do pairing, but the digit before the decimal will be paired differently and the digit after the decimal will be paired differently. I'll give one more example. Suppose I have 196.825. So this is decimal. Before the decimal, this is the pair and this is left alone. And after the decimal, this is the pair. I do not have pair for 5, so I simply put 0. Because after decimal, I am free to put as many zeros as I want. So this is the pair. So pairing method is little different in the decimal case. I do not pair something 19825. This pair, and this pair. This is going to be the wrong. Only the decimal you take After the decimal, start pairing just after this decimal. So this is the pair and this is the pair. But before decimal, the same way as we have done before. This is the pair and this is alone. Clear? Okay. So here I need to find out square root of 17.64. So let's write that. What we do? We put the division ka sign and pair it. After the decimal this and there is no digit, so no need to worry. Before decimal, this is the pair. Now, the same process, write a number here and here. Same number so that the multiplication should not exceed 17 and it is very clear it is 4. 4 4s are 16. After subtraction, I'm getting 1. Now what to do? As after the 17, there's a decimal. So push it upward. So decimal will come here and take the next pair. Now this number I need to add here and I'm getting as 8. Again, make a box here and here. Write a value such that the multiplication of these two with this last number should not exceed 164. So we need to do by trial error. This is 8. I can substitute 1. So which is giving me 81. But if I substitute 2, it is 164. Correct. So I need to put 2. The multiplication of these two is 164. Subtract it and it is 0. So the square root of 17.64 is 4.2. Clear? If you have any queries, you can comment me. I will definitely reply. Here the next is estimating square root. Sometimes we need not to find exactly, but nearest number. Suppose I have a number which is not a perfect square, means exact square root I cannot find out, but roughly I want what it is. So we have to take some rough number and find the square of it. Suppose I'm taking 10 and 20 and their squares are 100 and 200. Sorry, it is 400, correct? So this 250 is very far from both of these. Let's try next number. Suppose I'm taking 15 chi-square, which is 225. If I'm taking 16 chi-square, it is 256, correct? So see, the gap was very much. It means I have to increase 10, so I made it 15, and decrease 20, which I made 16. And 250 is very close between these two numbers, correct? 225 and 256, correct? Here the gap is 25, but here the gap is 6. So 250 is very close to 256. So what I'll do, I'll write the square root of 250 is approximately 16 because 16 chi-square is 256, correct? Like that, you can estimate the square root of other number too. In the next video, I'll be teaching you the exercise sums, how to practice them, and the correct method of doing it. If you want to join my online classes, you can message me on Instagram. My Instagram handle is same to same. Let's score full. You can DM me there and I will reply you with all the details. Take care and bye-bye.